Pulleys problems. When two bodies of masses m1 and m2 are attached at the ends of the string passing over a pulleys, mass of the pulley is neglecting. Here m1 mass is more comparing to the m2. At that time, weight of the body m1 g minus tension is equals to m1 into a, net force. Next, second mass, it is less comparing to the m1. At that time, tension minus weight of the body m2 into g is equals to m2 into a. From first equation, take it tension, T take it this side, m1a should take left hand side. Now T is equals to m1g minus m1a, substitute in second equation. T instead of T, m1g minus m1a, m2g as it is equals to m2 into a. This is second equation after substituting tension. Now g values, g take it common, m1 minus m2 is equals to this m1 take it right hand side, acceleration take it common, m2 plus m1. A is equals to m1 minus m2 by m1 plus m2 into g. Here comparing masses, suppose m1 is more, m1 minus m2. This value substitute in first equation. m1g minus t is equals to acceleration value m1 into m1 as it is there. Instead of acceleration, in this formula we are substituting. I want tension. Total value, take it left hand side. T take it right hand side. Now cross multiply. m1 into g into m1 plus m2 minus m1 into m2 minus m1. Now m1 into m1 g, m1 square, g take it common, m1 into m2, this is m1 into m2, after minus m1 square plus this minus whenever we are going in, taking inside, plus m1 into m2. Now m1 square, this is positive, this is negative, get cancelled. 2 into m1 into m2 by m1 plus m2 into g. Whenever we are taking two masses on pulley, at that time acceleration formula m1 minus m2 by m1 plus m2 into g. Tension formula 2 into m1 into m2 by m1 plus m2 into g. These two formulas directly we will use. Now a light spring passing over the smooth light pulley connects two blocks of masses m1 and m2 vertically. The acceleration of the system is g by 8. Then the ratio of masses. In this question they are given acceleration g by 8. Acceleration formula m1 minus m2 by m1 plus m2 into g. Instead of a, we are writing g by 8. g get cancelled. Now m1 plus m2 is equals to 1. m1 minus m2 is equals to 1. m1 plus m2 is equals to 8. Eliminate m2. 2m1 is equals to 9. m1 value substitute in first equation. m1 minus m2 is equals to 1. Now m2 we are getting m2 is equals to m1 minus 1. Now ratio of masses m1 by m2 is equals to 9 by 2 by 7 by 2. 2 to get cancelled, 9 by 7 answer. Two bodies of masses 4 kg and 6 kg are attached to the ends of the spring, which passes over the pulley. The 4 kg mass is attached to the table top of another string. Here two masses 6 kg 4 kg. 4 kg black we are attaching to the one more table using string. The tension in the string T1 is equals to, we want T1. Now first tension T is equals to m1 into G. In this tension is equals to weight. 6 into G value is acceleration due to gravity 10, 60. Now this side T, tension, both are equal only. Tension is equals to m2 into G plus T1. m2 into G plus T1. Now tension is 60, m2 is 4 into G value is 10 plus T1. 60 minus 40 is equals to T1, 20 newtons. When two bodies of masses m1 and m2 are attached to the ends of the spring passing over a pulley such that mass m1 rests in a smooth horizontal table and m2 is having vertically, at that time inclined plane, this black value is tension is equals to m1 into G into sin theta. These two bodies are equal. Net force is equals to m1 into A. Second body same as it is before we did. Weight of the body m2G minus tension is equals to net force m2 into A. Here instead of weight of the body we are taking m1G into sin theta. That means this weight we are dividing two components, mg into cos theta, mg into sin theta. This is normal. Now first equation we will write tension is equals to m1A instead of tension using second equation, so substitute tension value. Tension is equals to m1A plus m1G into sin theta. Substitute in first equation. m2G into m2G minus, instead of tension m1A minus m1G sin theta is equals to m2A. Now G value take it common, first term and third term, m2 minus m1 sin theta is equals to A, take it common, m1 plus m2. Instead of m1 we are taking sin theta. We are subtracting from m2 minus m1 sin theta into G by m1 plus m2, same as it is, but here inclined plane is there. Here it is making angle theta with horizontal. Next, after getting this acceleration, we are substituting in first equation. m2g minus tension is equals to m2 into acceleration. m2 minus m1 into sin theta by m1 plus m2 into g. After solving this, t is equals to m1 into m2g 1 plus sin theta by m1 plus m2. Whenever this system remains equilibrium, at that time m1g sin theta is equals to mg we will take. We will neglect tension. The masses of 8 kg and 4 kg are connected by a string as shown in the figure over a frictionless pulley. The acceleration of a system. Direct formula: acceleration is equals to m2 minus m1 sin theta into g by m1 plus m2. Here angle theta is 30 degrees, m1 is 4 kg, 8 kg, m2 is 4 kg. 4 minus 8 into sin 30. Sin 30 value 1 by 2. 2 ones are 2 fours are. 4 minus 4 is equals to 0. Acceleration value is 0. Now, 3 blocks of equal masses, each mass is 3 kg, are suspended by weightless strings as shown in the figure. If applied force is 100 Newton, then the T1 in Newton is equals to, G value is 10 meter per second square. T1 means downside we will calculate. T1 is equals to weight of the body, applied force. T1 is equals to force plus weight of the body. 100 plus m into m is 3 kg. Suppose T2 means remaining downside. We will add it. This is 130 Newton. Connecting bodies. 3 masses of 16 kg, 8 kg and 4 kg are placed in contact as shown in the figure. Of force of 140 Newton is applied on 4 kg mass. Then the force on 16 kg will be, we are applying 140 Newton, but how much force acting on 16 kg? That means here in between force we want. Left 16. Here total acceleration means applied force is equals to sum of the mass into acceleration. F is equals to A into m1 plus m2 plus m3. Acceleration acting on this body is A is equals to F by m1 plus m2 plus m3. But especially force on 16 kg mass. At that time 16 kg only we will take. m1 into acceleration. Acceleration value is F by m1 plus m2 plus m3. F is 140, remaining 28. 4 4s are 4 7s are 7 1s are 7 2s are. This is force is 80 Newton. Suppose force on 8 kg mass. At that time we will add it these two masses. 16 plus 8 into acceleration. Means m1 plus m2 into F by m1 plus m2 plus m3. Here. Next. Two masses m1 and m2 connected by a means of string which is made to pass over the light smooth pulley are in equilibrium on a fixed smooth wedge as shown in the figure. Theta is 60 degrees, alpha is 30 degrees, ratio in the mass. Whenever these two blocks are in equilibrium, at that time we are equating m1g sin theta is equals to m2g sin alpha. Now m1 by m2 is equals to sin 30 by sin 60. Sin 30 is 1 by 2. Sin 60 reciprocal we will take root 3 by 2. Now 2 to get cancelled, 1 by root 3. m1 is to m2 is 1 is to root 3. By what acceleration the boy must go up so that 100 kg block remains stationary on the inclined plane. The inclined plane is fixed and is smooth as shown in the figure. Now, tension on the inclined plane. T is equals to m1g sin theta. m1 is 100, g is 10, sin 30 is 1 by 2. Tension on the inclined plane is 500 Newton. Next, whenever the boy is accelerating upside, at that time T minus m2 into g is equals to m2 into a. Tension is 500 minus m2 is 20. G value is 10, this is 200 is equals to 20 into a. 500 minus 200 is 300 is equals to 20a. 300 by 20 is 15 meter per second square. Next question. In the figure, a smooth pulley of negligible weight is suspended by a spring balance. Weights of 1 kg and 5 kg are attached to the opposite ends of the spring passing over the pulley and move with an acceleration due of gravity. During their motion is the spring balance reads a weight we have to find out in terms of mass. Here m1 is equals to 5 kg, m2 is equals to 1 kg, g is 10 meter per second square. Tension formula directly we will use. 2 into m1 into m2 g by m1 plus m2. 2 into m1 is 5, m2 is 1 into 10 by 6. Now tension is equals to 100 by 6 Newton. Now two tensions are there here. Total weight we are taking in reading here. Now T plus T, 2T. Total weight T dash is equals to 2 into T in terms of kg. Now 10 value we are keeping as it is g. T dash is equals to 2 into 10 by 6 means 2 ones are 2 threes. This value is 3.33 into g. Mass value is 3.33. This value is less than 6 kg in options. A body of mass m is being pulled by a string of mass m with a force P applied at one end. The force exerted by the string on the body is, here body mass m attached to the spring mass small m, we are applied force P. Total force is equals to total mass into acceleration. Now acceleration is equals to P by m1 plus m2. How much force exerted by the string on the body? Body mass left, body mass into acceleration. Acceleration value P by m1 plus m plus small m. Consider the system shown in the figure. The pulley and the string are light and all the surface are frictionless. The tension in the string in Newton. G value is 10 meter per second square. It is there in horizontal. M1 block is there on horizontal plane. At that time, tension is equals to force. M1 into net force A. Next, MT is freely suspending. That means M2G minus tension is equals to M2 into A. Now, T value substitute in second equation. M2G minus first equation, T is equals to M1 into A. Take this side. M2G by M1 plus M2 is equals to acceleration. Now, M1 value is 1 kg, M2 value also 1 kg. M2 1 into G value 10 by M1 plus M2 means 2. 2 ones are 2 5s. Acceleration is 5 meter per second square. Substitute in tension. T is equals to M1 into A. 1 into 5. This is 5 newtons. Thank you. Please subscribe and share. Don't forget.